are about to enter the Invention Dimension, a place where you discover and uncover and activate the skills within you that you need to be an inventor. Sit back and relax and get ready to enter the Invention Dimension.
Welcome back. At this point in the invention process, you have identified a problem, researched to understand your problem and possible solution to it, you selected a solution to develop into a variety of designs, and you have explored materials and now built an actual prototype. Today's episode is all about testing and learning more about your prototype and how it works. Once an inventor has built a prototype, testing is really important. Testing helps inventors make improvements where necessary and gain valuable feedback from actual testers and data collection. Inventors take the information from testing and decide if they need to go back and make changes to parts of their prototype, and they summarize their progress in a journal. In this step, you will test your hypothesis. Remember, your hypothesis is what you thought would happen or might happen, or how your invention might work when you were seeking solutions. This is your chance to see if you were right and if it actually works. Take your prototype out to the places and people who would use it, if it were actually on the market, and get feedback. Create a survey and gather feedback from your testers. Keep track of all of this, as it is your data and will be useful to display and share later. They are collecting information about what didn't work to take into the next prototype or version. Inventor Thomas Edison said, "I have not failed. I just found 1,000 ways that won't work." And inventor Henry Ford said this, "Failure is simply the opportunity to begin again, this time more intelligently." That's the right attitude. Today, we will meet people who use testing every day to develop and create new solutions and prototypes. Come on, let's go and learn more.
When our students were working for Airstream designing a new trailer, there was a testing process involved. They started with a full-scale mock-up, we call these, typically made from inexpensive materials that are easily manipulated and changed. And in this case, it was mostly cardboard. We built a full-scale space to the size and dimensions of an Airstream trailer, had the students mock up the interior in cardboard, brought in a whole host of people to evaluate that, including the president of Airstream, Mr. Bob Wheeler, their head of marketing, their engineering team, and some test customers that gave the students critical feedback based upon things like, counter height and location and ease of traffic flow, and can I reach where the coffee is, and where's the light switch going to go. All of these things become critical decisions that the students must make. They learn from that feedback process, go back to the drawing board, make some adjustments and changes, mock it up again in cardboard, and kind of continue to repeat that process again and again until we get to what we hope is the best possible solution. We want them to test them against users, most importantly. How does the user perceive the project? Perception is oftentimes, a make or break in deciding if this is a good, viable solution or not. Obviously, you're also testing against manufacturing and capabilities and capacity. And the client often has a voice in that process. But the important thing is we want them to test. We want them to make prototypes, go out into the marketplace, have people try those out, get feedback, come back to the studio, learn from that feedback, apply that new knowledge to solving the problem, and move forward. And it's a fail fast and fail forward process.
Testing is an important step in the prototyping process. You have a prototype, you have to get feedback and find out if it works in test. Can you talk about how you test your prototypes?
Yeah, so it depends on what it is I'm prototyping. With things like when it's more aesthetic, then we're testing for form and we're asking people for their opinions. And there's different ways to do that. We would mostly take it to other people in different departments and ask them, which shape do you prefer and why? And still try to look for people within our target market. But when it's form development, that's usually in some way, shape, or form how you test it by showing others. And then if it's mechanical, it's really important to make an actual working prototype so that you can say, yes, this concept is valid and it can work.
Sometimes I experiment with different pieces that I can use in place of others to see if that will help. Like for mine, I kept on having this one piece that kept on coming out, so I tried to use a different screw for it. and it's working now. It's working now.
Modifying a screw made the difference for it to complete the task that you needed.
Yeah.
So you just had to keep testing and keep looking for the right material, the thing you needed, and it was a screw.
Yeah.
So for Bear in the Chair, we're working on making new patches. You need to put your toys away, go to bed on time, brush your teeth, and potty training badges. So then the kids know even when they're younger, and then they can use the bear when they're getting older, that they need to do this and not just have the happy or sad face patch on.
When Simone originally designed the product, it was for what's known in the marketplace as typical children. And it was really the autism community that reached out to us right after we were on Kickstarter to say, we really think you have something here for us, because there's really nothing in the marketplace for children with autism that helps them express their emotions. How can we use your bear to do that as well? It's like, absolutely. You know, honestly, it's not a market that we thought of right away, but one thing you learn is you have to pivot pretty quickly as a small business, and you have a marketplace telling you they want your product. You find a way to make it happen. So we connected, and now we're in 20 different states with kids in autism using the product. We were sending it to educators, and they were testing the product. And we knew, because it's only in happy face and sad face patch today, that there's going to be some limitations, but we asked them to use it as is and help us understand how would we do things differently. So they've started reaching back out to us, and we're in the process of working to figure out a line of patches for children with autism that may more align with kind of the teaching methods or the cool down methods in school that happy and sad face patch today may or may not help them with.
We saw all the different kind of birds, mainly understand how they want to be comfortable, because they're going to be in these bogs through a long time or a short time, depending on where their habitat is. So they need to be comfortable, and they cannot carry the box apart. So it needs to be, even though it's cardboard, it needs to be sturdy somehow. So it was a lot of thinking about what was the best structural solution to make this happen.
So this is one of the third or fourth prototypes of one of my inventions. This is what I call the oval Lazy Susan. It's for long tables so that you can get food from one end to the other without yelling at your mom or dad trying to get the mashed potatoes. And this is a model not in its final rendition, but it's got all the parts and pieces in wood, which will be nylon plastics and things that won't chew up or break itself apart as it does now. And I'm doing a small batch of about 50, and I'm going to run the 50 and test it field market. Next, I will be building the first full rendition of what will be for sale in materials with the full plastics, the paint job, so it looks all nice and pretty.
As you have learned in this episode from designers, scientists, and inventors, testing, redesigning, and summarizing your findings and data is a necessary step in arriving at a successful finished prototype. It can be fun and very exciting to watch people test your prototype and see how an idea in your head has grown into a usable gadget or solution. Making charts and graphs of your findings is a visual and creative way to show the testing you did and information you collected. Don't be afraid of criticism or failure. These two things give you knowledge and valuable feedback to help you improve and make the best prototype you can. Don't forget how important your journal or notebook is in every step of the invention process, but especially when you are testing your invention. By now, you know failure is not a bad thing, simply part of our learning process. It tells us what we can do better, differently, and how we can improve. Being an inventor can be hard work, and most times your first prototype is not successful. Inventors don't give up or see the process as a failure. They are collecting information about what didn't work to take into the next prototype or version.